We can hear you, madam. Just we will start in 2 to 5 minutes.
Sure.
Thank you, madam. Thank you.
Good morning, all. I am Dr. K. Saujanya, Assistant Professor in the Department of ECE and Coordinator for this conference. I welcome you all to the second day of 5th International Conference on Computer and Communication Technologies 2023. Today we are having a keynote address by Professor Mathini Sellaturai ma'am and followed by a technical talk by Professor Sushant Babu sir. So without much delay, let's start our today's session. Let me give a brief introduction of Professor Mathini Sellaturai ma'am. Professor Mathini Sellaturai is currently the Dean of University for Science and Engineering and a full professor in signal processing with the Herbert Ward University, Edinburgh, UK, and leading research in adaptive, cognitive, and statistical signal processing techniques in a range of applications including radar, LiDAR, sonar, and RF networks, network coding, cognitive radio, MIMO signal processing, satellite communications, and underwater communications. She has been active in signal processing research for the past 15 years and has a strong international track record in multiple input, multiple output signal processing with applications in radar and wireless communications research. Professor Sellaturai has 5 years of industrial research experience. She held positions with Bell Laboratories, New Jersey, USA as a visiting researcher and with the Canadian Communications Research Center, Ottawa, Canada as a senior research scientist. Professor Sellaturai has published over 120 peer-reviewed papers in leading international journals and IEEE conferences, given invited talks and written several book chapters as well as research monograph as a lead author. Dr. Sellaturai was the recipient of the Natural Sciences and Engineering Research Council of Canada's Doctoral Award for her PhD dissertation. I request Professor Sellaturai ma'am to take over the session. Sir.
Okay, thank you. Good morning, everyone. Just hold a minute while I share my screen. It's not letting me share it. I don't know why. Because Okay, good morning, everyone. Again, I hope you are having a great time there and you had a great session yesterday. So I'm going to talk about the 5th generation IoT based device that we have been researching and developing, basically. So this is basically to clean the noise in the multimodal hearing aids and hearing devices. So the idea is to clean noise when we are using some sort of hearing devices or hearing aids, because these hearing aids and hearing devices are really affected by the surrounding noise. Okay, they reduce the quality that they provide for the people who are wearing devices and aids, hearing aids. So this has been a long-standing problem as well, because we all have, most of us have good hearing, so we don't really understand. For those who have good hearing, can't understand the difficulty faced by the people who has no hearing, no good hearing, and they using hearing aids. So this project going into developing such kind of devices. Okay, my name is Martini Selature, and I'm a professor at Harriet University. I've been working in signal processing communications for a long time. Um, so this project we call as COCMIA. So the idea is here, like, the COCMIA is the cognitive and multimodal hearing aids and hearing devices. So the idea is to bring some sort of hearing devices and hearing aids. Those can actually cancel the interferences. I'll go into detail why we cannot cancel the interference currently in these small devices, and why do we need to make them as an IoT. What's the benefit of them, and what's the chances that we can achieve such kind of devices. So that's what I'm going to talk to you today. So the background is, so about 430 million people worldwide needing some support for their hearing. Okay, they have some hearing problem. So that's a huge number of people. So they have some sort of hearing loss or hearing effect that is severe enough that they would need some sort of hearing device to help them. Otherwise, they cannot have conversational speech. If people have problem hearing, they cannot actually involve in conversation. So they're trying to isolate themselves if they cannot involve in conversation. So they need some sort of support. So there's a huge number of people needing that. But you can question me saying that why not? There are hearing aids and there are hearing devices. Why can't they use them? The problem is these hearing aids just amplify everything that it record. Like, if someone wearing hearing aid, it will amplify the noise and also the sound. So that become really, really nuisance to them. So it is not an easy thing when they wanted to try to involve in a conversation in a noisy environment. Okay, so we actually had a project called COCMIA, so that's a cognitive multimodal hearing aid. It's supported by UK Research Council, that to develop these hearing aids as a next generation IoT. Okay, so it goes in the fifth generation of communication IoT, audio-visual hearing aids and devices. So the idea is to not only just take the sound, like the current hearing aids just take the sounds and amplify. The proposal is to take not only the sound, but also the lip movement and the facial expressions and the other hands movement and everything, and to train a network that can actually remove the noise, including all this information. Okay, so it's a normal human. You're in a conference, you're probably having the same experience because you have been talking in a very noisy environment with another person. When you do that, to avoid the noise, what you do is you're looking into the person's face and you look the lips movement and also the facial expression along with the sound to actually focus on that specific sound and remove the noise for the ear. Okay, our brain does that usually. So to bring that same level of experience for those who have no hearing or those who have hearing loss, we propose to do audiovisual hearing aids and devices as 5G IoT. Okay, so this is a group project. This has a large number of partners. So I like to acknowledge all the partners as well. And there is a website, cognia.org. You can go and check the website as well. So this university, the universities involved in this project are Edinburgh Napier University, the University of Edinburgh, University of Glasgow, Stirling University, Harriet University, which I am from, Manchester, the University of Edinburgh, the University of Nottingham, and also a number of other companies involved in this. Okay. And so just coming into the talk, so this hearing aid is now connected to wireless communication. That's what I hope for. So I just had a brief introduction for the wireless communication. The growth of wireless communication is started in 1945. The digital communication, basically, the communication started way before, but the digital communication started in 1945, and then they started developing. Initially, they only developed the analog communication up to second generation. Okay, so the 1945, that zeroth generation, they have a telephone like this, and then the first generation, they started to have telephones. The second generation, we have some sort of text phones. That's in 1990s. That's not too far away. And then third generation. From third generation onwards, we have much more sophisticated phones. So that started in 2000, just like 20 years ago. Okay, there's a very short time that we are having such a sophisticated phones since. And then we have much sophisticated phone. Now you have really sophisticated phones. So next level is going to be going beyond phone. Okay, so it's going to be, we went from digital analog to digital, and now we are going in the edge cloud era. Okay, so the idea is not even phone. You know, we having very sophisticated, very nice phones nowadays to do most of the communications and also most of the applications. But in the future, in the near future, what we're expecting is reduced capability devices. Okay, the watches and VR, AR glasses and smart glasses and all the equipment things are connected to internet. So large number of devices will be connected to internet. Okay, you can connect anything you want to the internet, so you can actually track them, talk to them, and you can identify them. Okay, so that comes because we went from digital era to edge cloud era. So I mean, I don't know how many of you have experienced this, but within the past 10 years, what happened is before that we were carrying devices, we were backing up things in storage devices like USBs and CDs and so on. Now nobody is backing up anything. We are throwing all the data, all the things that we want to store, all the things we want to process into the cloud, edge cloud. Okay, we are throwing some other computers through wireless most of the time. So even if you have a laptop with you or you have a phone with you, most of the time, like you actually save all your stuff in a cloud. Okay, so you don't save on the device. So the device size can go down smaller and smaller. Okay, so that has been happening for the past maybe 5 years, but in the near future, what we're expecting is much more devices connecting to the cloud, okay, and also doing the processing, and also doing low latency communication processing. Okay, so we wanted to do any processing really quickly and return it within like millisecond level, like 10-20 millisecond level. Then what happens is we are just still trying to develop technologies that can actually do that kind of very fast computation and then very low latency. So we call it ultra reliable low latency communication devices. Okay, so we have been you have been heard, and you probably have been working on autonomous cars and so on. Those also will need very low latency communication with ultra reliability. Remote surgery. So they are some mission critical application, but there are some devices that we are the smart glasses, virtual reality, and those things also will need very fast computation and very low latency. Okay, so in that category we can actually put the hearing aid as well. Okay, so as an edge cloud device. That's also a very small device, and that needs computation very quickly because we don't want to have a delay in the speech for the person who's hearing of speech. and it cannot be done in the very small device because the device is very small. So that's the idea. That's the framework that we are going into this research. Okay. So this is just a reminder of what 5G is. So we are talking a lot about 5G. Which started in 2020, and it is hoping to be developing further until 2030 before it moves to the next generation. So usually each of the generation communication stays for a 10-year period. So the reduced capability devices will come as IoTs, okay, Internet of Things. The standard for reduced capability devices were introduced this year. Okay, so the version 18, so the 3GPP release 18, which is released this year, has reduced capability devices, and in both cases, large number of reduced capability devices which are not sensitive to time delay. Okay, for example, smart meters, that's already been there, but improved level of coverage, asset tracking, transportation tracking, utility meters, smart city. Some of these do not have a requirement for very, very low latency, but the number of devices that will be available will be huge. If everybody started to track their parcels, how many parcels um, being sent every day, so everything has to be tracked. And they wanted to track their assets and agricultures and utility meters, smart meters, and electricity usage. To everything is tracked through the wireless, through the IoT. Okay, it's a large, very massive machine type communication. IoTs we call. Okay, the second kind is the ultra reliable low latency communication. So it needs really, really high reliability and really, really low latency. But they are like really critical application that can cause severe damage if we don't have this kind of requirements, which is 5G is expected to support these activities. Okay, so autonomous driving, augmented reality games, virtual reality, smart factories, smart grids, and remote surgery. And then we wanted to try to put the healthcare, Internet of Things, some of the things that need goes under this um, ultra reliable low latency communications as well. So this one other thing is hearing aids and assistive care robots. Okay, they had to be on time. They had to work really, really quickly without making a big mistake. Okay, so these are real challenges that we face currently in the research domain and also the development domain. So that's one of the introduction. The other one is the edge cloud processing. Okay, and it's an additional level of processing. It started like people started to store their pictures, and the cameras, the quality of the pictures that we take has been going up, and we started to carry very small things like phones, which take photographs, and but we cannot store all the thing on the phone because the storage capacity we have is very limited. So they initially started to send these photographs from the phone to a cloud. Okay, so the blue layer is we call cloud. So eventually we started to send all of the information, big data, So even we have phone, we're reading our emails, we're downloading our documents and everything. These are all stored in clouds. Okay. So this framework has been developing, and now it's it's becoming a place for us to do computation as well. You probably have cloud storages and cloud computing platform where you throw your simulation. You don't use your laptop to do the simulations and so on. Even for research now, you just throw it in the cloud. Similarly, we wanted to do like very quick calculations like that we need within milliseconds. I need the answer in milliseconds, but still I wanted to throw my communication to cloud because I can't carry really heavy computational power in my small devices. Basically, there's two reasons. One is that it needs to have computational power, so we cannot put those significant computational power in a small device. The second thing is when you do some sort of computation, it takes power. So we usually use battery powered small devices, and we don't want to use that battery die every day. You wanted to keep that for a year or so. So that's two reasons we wanted to throw all the computation to cloud. Okay. And the only difference, like it's already there, but it's slow. Like, you don't have to be fast. But now we want very quick computation. So that's the only difference that needed. But it's easy to say that I only need a very quick computation. That's the only difference. But making such a system is not that easy, because you need to be very prompt in sending, and then it has to have an availability at the cloud and immediate computation and return it. Okay, so it's going to be a round trip delay. So most of the remote surgery, autonomous cars, and hearing aids and so on, that we adding more and more healthcare devices, assistive care robots and so on, they all need very quick round trip time. Okay, that's in milliseconds, like 10-20 milliseconds, which is really, really harsh. But people believe, and there are, we have been developing and testing as well, and it's possible in the 5th generation of communication systems. Okay, so again, when we're talking about this, it has the red text you can read, the sensors. We need sensors at the edge devices most of the time. Okay, so if we sense the environment properly, only we can get the computation done. And then some sort of intelligence, like human intelligence, artificial intelligence is needed. We cannot just do conventional signal processing most of the time in this. So that introduction of the layer called fog layer and distributed intelligence. Sometimes, like, you cannot make a decision. Like, as a human, what you do is you approach a few people and discuss and get the results. Okay, so here also we have a fog layer called that can actually distributed intelligence, that we can communicate with multiple sources to get a solution. So that also has to happen really fast. Okay, this is a framework that we are going in the future for 5G, which actually hoping whether these things will happen within the 5G period or will go into the 6th generation communications. Okay, so the idea of our project we are hoping a 6th generation communication in 2030. So mostly that the research is going to go in this decade, but the application of the devices will be developed in the next decade, hopefully. So our project's idea is to support people with different ability, like, it's a hearing aid. That's one of the examples that we took, but the same technology can be applied to control wheelchairs and people who have visual problems. Okay, they can't see. They can actually use the technology, because we're going to develop a technology, a smart glass technology, which supports the hearing aids, but the same technology can be used for people with visual problems. So this is the whole set of applications that we are looking at, and also assistive care robots. Okay, these are the 4 applications we are looking in our development. Okay. So the next thing I'm coming, like, mainly going to go into the hearing aid design. To do that, before doing that technology, I'm going to talk briefly about the hearing issues. Okay, the challenges faced by the hearing issues. So the picture you see in the top here it's the inner ear. Okay, inner ear. So this actually connected to the brain, and it just helps us to take the sounds in the ear and to process it in the brain for us to hear. It's like a speech. Okay, so it's a process, and it's very complex but intelligent process. It's the ear is very intelligent. It's one of the most sophisticated thing that we do anytime, and it's almost supporting us throughout the um, life. Okay, So people who can't hear, they're in danger basically, because this alerts you the loud sounds and alarms and fire or train coming behind you or car coming behind. Everything is alerted by the ear. So the people who can't hear actually get into trouble because they don't hear. Like even if they're standing in front of a train coming behind them, they can't hear it. So that's a huge problem. So the hearing is really an intelligent process, and it's really integrated process with our brain. It just takes a number of different things, and the sound is taken by ear and it's interpreted to our brain to as a usable thing, and the main starting point is called tensor tympani muscle. So this is our eardrum we call. So all the sound go in vibrate the eardrum. So that vibration is taken by the ear and it's converted into sound. Okay. It's not like we just take sounds as sound because that's an interpretation of sound. Okay. For everybody has different interpretation. We can't actually share that. Okay. Similarly to the vision, it just takes light and then it interprets the image for us. Okay. So it's a huge scientific process going in our human body. And for the sound, the bottom picture you see the audiogram. Okay, so the hearing in the decibel, the loudness on your y-axis, and the x-axis is the frequency. So that's how this picture is shown. And there are different, like dog barking has a different frequency and different sound level. At the same time, if you have telephone ringing has a higher frequency usually, and it has a different sound level. So it goes under severe, and the dog barking and things are moderate, and then there is mild, very simple, soft voices. Most of the people speaking in the mild, some people speak in the moderate, some people will shout that will go into severe, and lone movers and alarm, fire alarm. Everything has a different level of sound and different frequencies. So in order to be able to hear everything, you need to have a perfect eardrum and perfect hearing health. Okay, then eventually people start to lose hearing. They will lose some part of it. So for those we are hearing it, it has to be tuned to their problem very well. So it has to be really personalized as well. And that's one of the thing that we can do using IoT hearing aid very easily. And the other thing is in a noisy environment, it's like in a really huge noisy environment, it's very difficult to hear. But our intelligence and the knowledge that we have about hearing and people, what we do is we can look at a person and then we can actually forget about the surrounding noise, and we are able to hear the person speaking even in a very noisy environment. So this is because we are kind of unconsciously know the lip movement and the facial expressions and so on. And also there is directional speech that we have 2 ears. We can actually kind of switch the ear to a directional speaking to look at a different direction. So these all support for us to hear, but people who are wearing hearing aid, they kind of lose that. Um, Usually, they lose the spatial, the beamforming aspect of the hearing, and also it's very difficult for them to coordinate the facial expression and the sounds they're receiving from the hearing aid. So the idea is to take this problem and trying to bring a hearing aid that can actually see the lip movements and also the sound in the hearing aid. Okay, so that's the idea that we were going into. So that's the challenge with the hearing. Okay, so hearing is a very sophisticated thing, and then how that challenge translating into designing hearing aids and hearing devices. Okay, so the current hearing aid technology, although it's very small, people wear very tiny hearing aids. It cannot do a lot of processing. It's just amplify everything. Okay, it's just make everything louder for them. Okay, so that's not the solution for people who have hearing problem. Okay, because it needs a lot more sophisticated processing to remove noise and so on, but we don't have that at present. And there is a tiny history in the bottom picture. There's a tiny history of how the hearing aid technology developed. The hearing aid technology has an interesting story, and it's almost has equal history of telephone. Okay, telecommunication development, because the hearing aid started from the same person, Alexander Graham Bell, who actually invented the telephones, and his wife. Okay, so his wife had hearing problems, so they were developing hearing aids when they started telephone company as well. So it has equally, I don't know, 100 plus years of 140 years long history of developing hearing aid. But early years they had bigger devices, you know, because the technology wasn't there. Like, with the time, according to most theory, we were packing more and more digital and analog devices in a small equipment. But before it wasn't the case. So they had huge hearing aids, like like big telephones. They also have hearing devices that they hold. Okay, but effectively with the technology growing, it becomes smaller and smaller. And then, unlike glasses, there is a stigma about wearing hearing devices. So people like to have very tiny, tiny devices for hearing. Okay. So although the technology is grown, we became to hearing devices of very small sizes. So we cannot put a lot of processing in the hearing devices. So it still use a basic amplifying. It's just make every sound louder. That's all it does. Okay, most of the time. So the present technology, although the technology become much more sophisticated, it doesn't include noise cancelling effect. So people don't like to wear big hearing aids as well. So they like to wear tiny ones. So how do we solve that? So that's where we introduce the concept of 5G Internet of Hearing Things by offloading all complex processing to the clouds. Okay. So what the hearing aids we are imagining is taking the sound and sending it to cloud. The cloud clean the noise and then it return the clean sound back to the hearing aid. It has to happen very quickly as well. Okay. So just the sound is not enough to clean noise most of the time. So we had to actually send other information. So some of the information, visual information, speakers' lips, hand gestures, and language switching enhance things to enhance the speaking. So we can actually send a lot of intelligence to the cloud, and then the cloud can process and return. So this is hypothetically this was the idea. So here is a picture of it. So the person with hearing aid, he also wear a smart glass. Okay. So the smart glass can have multiple purpose. Okay, it can be their normal visual correction glass, or it can be a virtual reality glass, or it can be something like sunglass that we wear like to protect our eyes. So it can be combined with multiple purpose. Okay, but it will have a camera as well. So that's the idea. So the person, I'm say assume that I have problem with hearing, so I'm wearing hearing aids and I'm wearing a smart glass going with that hearing aid. So I can look at the person who is talking to me, so I can actually capture the lip movement and the facial expression. So assume that there's a huge noise around us. So I can capture everything, and then I can send the noisy audio and the video. Assume that video is pretty clean, and it goes to cloud, and here is my brain sort of processing. So this is a neural network model that we developed to clean the noises. It's sitting in an edge cloud, and it does the cleaning process immediately and return it. Okay, and then this goes to the hearing aid here. So I'm doing a conversation. I'm sending all the things to the cloud and clean and returning. But if I need to communicate with the other person, I need to get these things done in like within 50 milliseconds or so. Okay, so the round trip time and the cleaning, round trip plus cleaning time has to be within 50 milliseconds. Whether it's approachable or not, that's a question, but it's approachable with 5G. Okay, 5G and beyond communication system, it's possible. So this is the concept. It needs a number of things, buffering, and how we're going to buffer the speech and audio and video detail. They have to be matched another thing. Okay, you cannot, if you send unmatched lip and the speech, then it will give problems. So it has to be really intelligent and capturing these and framing and buffering and transmitting continuously, and then in the cloud immediately process, clean the noise, and return it in the correct order. Okay, so these are the challenges. I mean, we're developing a practical system. And in these slides, I have slightly more details in the sense we have two scenarios. One is we capture all this video and speech and we transmit. That's called uplink. Okay, transmit the cloud. Okay, so the capturing device here is going to be a reduced capability device. It doesn't have lots of power or it doesn't have lots of capability. It can just capture and transmit. But we minimize the processing that we do in these small devices to avoid overheating or use most of the power or to make it bulky. Like, we can have a simpler device for people to wear. So we don't want to make it bulky as well. So we just don't do any processing. We just capture and transmit. Okay. So raw data will be transmitted. Here the cloud can be big. So it's not carried by a person. It's probably sitting in a base station or in a place close to it. So it can actually do the processing. The cloud is going to be it's the intelligence. So it's going to be like our brain. Okay, so all the processing can be done. It can be huge. It can be fast. It can be parallel processing. Okay, whatever we want, we can put it in the cloud. And then cloud auto processing will do the transmission, and the reception has to be very simple as well, because the same simple device is going to receive it. So ideally, we want to keep our reduced capability devices very simple. We don't want to put any processing. Throw all the processing in the cloud. Okay, so this is how we develop. So there's a concept, the theory, and so on. We can actually put it in further theory, like semantic communication theory as well. But we were more interested to see how this works. Okay, so we got an access to 5G accelerator, which is developed by Cambridge Wireless. There's a company, so they offered us to use their 5G private network. So they have a 5G network. So we actually developed the on a phone app. We developed the phone has, like, we cannot develop the hearing aid straight away. That needs a lot of effort and technical challenges that we don't have. So companies can develop easily. And also the ethical problem using on people unless we have the sophisticated devices developed. So first attempt was to develop on a phone as an app, which has a camera and the microphone, so we can speak on a phone in a noisy environment. And then the data will be transmitted to the 5G network, and then it goes to cloud, process, and return it. Okay. So the noise cleaning model is sitting in the cloud. It's a real cloud. We were speaking on a phone, and it's transmitting through the 5G private network, going to the cloud, clean it, and return it through the 5G network. The 5G network is really quick, so you can actually be sitting in, for example, Edinburgh to send to London and return it. It would take sort of millisecond level, like 10-15 millisecond level. The delay is very low because the speed of communication is like speed of light, and the 5G private network has sufficient technology that can actually make the computations fast. Okay, travel, and also have enough channels and so on. Okay, so this is a model that we developed, and as I said, we are on the phone now. The next step, we were planning to do the smart glass and connect with the hearing aids. Okay, so that hasn't happened yet. So can't we do this in the Wi-Fi, or can't we do in the 4G? Lots of questions us on this. The reason we can't do in the 4G and 5G is, like, the 4G and Wi-Fi, they develop in the hope for very low data rate for uplink. Okay, so the up to 4G, the communication system we developed, we thought that we only need really, really big data rates on the downlink because people just request, I want this video to watch on the uplink, and the downlink has to send the video. So most of the bandwidth is allocated for downlink, not for the uplink, up to 4G and Wi-Fi. Wi-Fi 5 and Wi-Fi 4 also has the same problem. Mostly it's assumed that people are going to download a lot of data and going to request so very little data for uplink. So this, but the 5G and also Wi-Fi 6, that started to realize that, people are also uploading now. Like we are uploading, like people have less interest in watching now, more interest in sending their videos. Okay, the human nature is changing. So the 5G has really high uplink data, like 10 gigabits per second. Okay, 4G only have 150 megabits per second. Okay, Wi-Fi 5 is 650 megabits per second, which is good, but Wi-Fi 6 will have in gigabits per second. So that goes with the 5G. So that's one main reason that we need 5G for this kind of technologies to perform in a good quality. Other thing is the low latency. 5G only support less than 10 milliseconds. The Wi-Fi's and these things can't support that. So 5G is really critical for us for this. And so we developed the technology in their 5G private network. And here is some results to show like the latency. Here, this graph has latency on the y-axis and the communication time, number of packets here. This is for basically 5G or wire connection. This is for 4G or low Wi-Fi kind of connection. So you can see that a few milliseconds is enough, depending on the distance. If I put my cloud like another continent, so for example, interesting thing is we actually connect the cloud in Sweden, for example, from Edinburgh, which is not that far, but we can still get like 10-15 millisecond delay only for that. Okay, so this is very short distance, so we got only 4 milliseconds, and it's very stable when we have 5G. Like the delay is very stable. But when we go into 4G or Wi-Fi, the delays can be like up to a second. Okay, so you see this, it can be like 400, 300 milliseconds usually, and it fluctuates. So this is the main reason why we needed 5G for these kind of technologies. The 4G and Wi-Fi cannot. The latency is huge, and also we don't have the uplink data. So that's one of the reasons for the long latency as well. Because what we had to do for Wi-Fi and 4G, we had to compress and then send it and process in a compressed data, because the uplink data rate is not supporting a raw data transmission. Okay, so that's one of the reasons for the higher latency as well. Okay, so here what I'm going to do is, I don't know whether you can hear it, hope you can hear it. I'm going to show an example of what we did. Okay, look at this. This is a phone app that we developed, so a person can speak on the phone in a noisy environment. What it does is take the lips and the facial expression and along with the sound, and it sends it to cloud, and processing is done in the cloud and returning with clean speech. So I have this is a sort of an app that we developed. I have a sample of the noisy speech and the clean speech. It happened through the cloud. Okay, to show you. So hopefully you can hear it. If you don't hear it, just tell me. Okay. So this is two people speaking, okay, at the same time. So you can hear that. Did you hear the two people speaking? Okay, so assuming that you're hearing, because I cannot see. So this is a clean speech, okay? If you cannot hear it now, we will try at the end of the speech again, okay? So if two people speaking here and somebody who wearing hearing aid or hearing device trying to understand one of the speeches, because it's talking like it's like a conference environment, there's 2, 3 groups speaking at the same time, so we need to listen only one person. So there's 2 people speaking in the noisy, but with the noise cleaning aspect that we develop in the cloud, so they send these 2 speeches to the cloud and clean it and return it one person's speech, which the person we are looking into. Okay, so that was really, really useful thing for hearing aids and hearing devices. So I'll show another way of demonstrating this. Okay, so we have real world bar noise, for example. See, sorry, the noise is like somebody speaking in bar, for example. So the surrounding noise is like really, really heavy. So this is a spectrogram of the noisy speech. You see, the speech is not very well defined because of the noise, and you can see the time amplitude representation. So because of the noise, you see this is really full. Okay, it's not clearly defined this for the speech. It's noisy. And then after processing, we get, the speech. The noise is clean. You can see the speech time amplitude representation is very clear. And also you can see the definition of the speech is really much clearer compared to this one. So this is what happened when we were doing the processing in this picture. That the earlier one I showed you how the sound will look like you can hear, but here you see this picture of the sounds. Okay, so as I explained, the 5G is critical for this because we also tried with the 4G and Wi-Fi. Because the uplink data rate is very, very small for Wi-Fi and 4G, what we did is we did the compressed lips and a compressed phase. This is the original one we were sending in the 5G, and the 4G and Wi-Fi we were sending the compressed one. You can see the definition is reduced. And then we did very low quality sound clearing. So this is a major problem with the 4G and 5G. You need to compress a lot, and then work on the compressed domain, not which is to not increase the computational latency. Okay. So the 5G is very critical, and then the other thing is, as I said, more and more people are going to use it. If you develop really nice device, and a lot of people will be using it because it's very convenient to use them rather than not using them. So in that sense, we need to have number of channels for everybody. So Wi-Fi and 4G cannot support large number of users. So the 5G is very critical for multi-user communication here, multiple device scenarios as well. So that's basically we developed to prove the concept that we initiated. We said that we can actually put these hearing devices as an IoT, so we can send, offload all the processing to cloud and have a very quick return time for people to have good experience. Okay. So that we were able to prove because we got access to 5G private network. And the next steps that we are doing is we are developing lightweight algorithms, reduce CPU utilization, very effective and efficient algorithm, and also improve noise cleaning, improve speech intelligibility, how to use 5G cloud technology in much more efficient way, and also leverage the number of sophisticated technology like WebRTC and multi-target detection and so on. And also we had to keep testing these devices because we just done basic testing, whether this would work in longer term communications, and what are the challenges we will face, and when we don't have enough support from 5G and so on. So we had to keep testing. So that's what we are doing now. And the next step will be introducing to wheelchairs, people with vision problem, people with hearing problem, whether we can actually bring this technology into these devices. And another thing that we did is the robotics is developing as well. So robots are machines, but they are trying to act like humans. They don't have intelligence like humans, so they need to clearly hear us. If they hear something slightly different, they will do completely different thing. So in a noisy environment, if you're trying to order something through a robot, it might not hear you well. So the noise cleaning algorithms and the IoT model that we develop can be useful there. Okay, and this is a phone app that we developed as well, real-time noise cleaning in phone apps. Okay, in a phone, and there are other applications that, like in an industrial noisy environment, phone conversation in a noisy street. You're trying to talk to. So you usually talk in a noisy environment. The person who hearing is going to hear all these noises. So if you have this lip facial capture with the thing, it can actually effectively clean the noise for the person hearing other end. So, and the human robot interaction, and augmented intelligence, smart glasses, smartphones, everywhere that we can use. And also we can also support the equality, diversity, inclusion, like we can include people with hearing problem, vision problem, and mobility issues to benefit from this technology. Okay, so that's the whole idea. So this is kind of the first time development of such reduced capability devices, and it's a multidisciplinary work, and image processing, feature extractions, and face recognition, speech intelligibility, noise cleaning, and multi-target speech extraction. So multiple people speaking at the time, we can actually extract each of the speech in a very effective way. Software development, we wanted to bring into as an app kind of thing, and also circuit technology, IoT, communication framework, ultra reliable low latency communication. I mean, it's really a multidisciplinary project, so there's so many different areas that you may be interested in might help here as well. So it's a huge opportunity for collaboration and enhanced knowledges as well. So we're looking for people who are interested in this kind of thing to do more work and share with us and or work with us and so on. So there's a lot of collaborative opportunities on this, and then. My main research is 5G communication at the moment, so there's reducing the latency further on comms, high data, how we can actually manage high data for IoTs and so on. So these still faces challenges. There's a huge amount of work to be done as well. And the next thing is, like, because we are working on healthcare devices, we need to think about standardizing as well on the side. Okay, so these devices bring a number of problems like trust, identity, privacy, protection, safety, security, and they can be multiple benefit, multitask oriented devices as well. So, for example, because they come with various technologies, they can be used for various different things at the same time. So there are two standards are developing. I've been part of it as well. One is actually in a later stage, other one is just starting for disabled people, augmented reality, and so on. So there's here anybody can join. These IEEE standards, so you can join IEEE standard committee and become part of this, and put your inputs and also learn from others and so on. So there's huge opportunity for those who are interested in this sort of things. And then the next thing is, okay, these are really nice. We demonstrated, but how are we going to bring it to real life? That brings additional challenges that can be done as well. Okay. So yeah, we have a website which has a number of different demos, and new demos are coming as well, so you can watch them if you're interested. Okay, and I don't know how much the timing point of view, so I think I've used most of my time, so thank you very much. um, um, so I'll hand over to the organizers. Thank you very much.
Thank you, ma'am. I request the participants, if you have any queries, you may ask. You can go.
Ma'am, how can edge cloud processing improve the efficiency of sensor data analysis?
There are a number of, like, even we face these challenges. There's a number of things that you have to do. It's not one thing. So, how do we frame it? How do we transmit, buffer, queuing, and every part of it has to be improved. And the processing can be parallel processing. If you think that can be parallelized to make improvement.
Hello? Yeah,
Yeah.
good afternoon. Myself, Dr. Amreshwar Reddy. Yeah, how to improve the latency rate, madam? Latency in these communication systems. What is the lowest latency rate that is observed so far? The
Yeah,
method
the
latency.
yeah, the 5G can reduce the latency because it can have a higher data rate. Like, so you can actually pack a lot of information in the bandwidth. So you can actually send it quicker. So it can be like, depending on where you edge cloud, it can be a few milliseconds, like 1 millisecond or less than 1 millisecond if your cloud is closer to you. But what we experienced when we were doing testing from Cambridge, if we had to send it to London, it was 7 milliseconds through 5G. But this can be like 20, 25 millisecond if you're using 4G or if you 5G Wi-Fi. So the 5G has this low latency thing, but then we have to do our own processing as well. Yeah.
Thank you.
It's up to us. It's our processing. Okay. So the sense, depending on the sensors. So if, for example, you want it, like, for example, if I can't see, so if I have visual issues, what I can do is I can capture using a smart glass the images and send it to the cloud, and the cloud can interpret to me what's going on. So depending on the application, it's up to your processing. Okay, the cloud can't do it. The cloud is a facility it has a lot of processing capacity. You can put GPUs for parallel processing, good CPUs for you know which you cannot carry in a small device. The thing is, you need to develop the network. So it's a part of research. Yeah.
Any more queries?
Feel free to email me. I'll put my email address, if you have further questions, and
Oh, okay, ma'am.
contact me if you're doing similar thing, or if you would like to do similar things, or take some ideas for your projects and so on. So feel free to contact me.
Thank you so much, ma'am, for delivering such a wonderful and knowledgeable keynote address on 5G IoT noise cleaning, multimodal hearing aids and devices. Thank you, ma'am.
Thank you. Thank you very much for inviting me. Thank you.
So for your session, ma'am, in offline also, almost 150 students have been presented for your session. Thank you so much, ma'am.
Thank you. Bye. Have a great day for the rest of the day.
Thank you, ma'am. Participants are requested to just wait for 2 more minutes for the next session. Now moving on to the next session, here we have Dr. Sushant Babu sir from CBIT. Welcome sir to the second day of International Conference on Computer and Communication Technologies 2023. Let me introduce Professor Sushant Babu sir. He is a distinguished educator and director academics at Chaitanya Bharati Institute of Technology, Hyderabad. With an impressive 22 years of teaching experience and a strong background in wireless communications, cooperative communications, vehicular networks, and 5G, 6G communications, Dr. Sushant Babu is a beacon of knowledge in the field of electronics and communication engineering. Dr. Sushant Babu's educational journey is marked by excellence, including a PhD in electronics and communication engineering. He is a recognized guide for PhD scholars and has actively contributed to the academic community through research, publications, and leadership roles. As Director Academics, he has taken on significant responsibilities, including membership in the College Academic Council and coordination of various accreditation initiatives. Dr. Sushant Babu's commitment to quality education and research is evident in his numerous accolades, publications in esteemed journals, and patents. In conclusion, Dr. M. Sushant Babu is a distinguished academician and administrator whose contributions have left an indelible mark on the field of electronics and communication engineering. His dedication to advancing knowledge and promoting academic excellence is truly commendable. We are honored to have him as a part of our academic community. Thank you. I welcome Dr. Sushant Babu sir to continue his technical talk.
Yeah, that's fine. Yeah, good morning, one and all. Yeah, being a localite of Warangal, again back to Warangal, it's a happy moment for me. And I thank the organizing committee members, head of the department of EC, faculty, and the conference crew. Thank you for giving me an opportunity to express myself on vehicular communication in 5G. So, as madam was saying, I pursued my PhD under Professor Kishan Rao Garu, who was former principal of this college, under 4G communication, and right now my students are pursuing their PhD in 5G communication. So today my topic is on research challenges and solutions in vehicular communication in 5G. I think most of the participants here, I observed that few are the faculty and few are the students. You might be studying different communication subjects, and right now, what are the communication subjects you are studying, their implications will be with respect to applications in 5G. And to our knowledge, right now most of the work is already concentrated on the 6G, but still there are so many research problems yet to be resolved under the 5G communication. So one among such type of applications is vehicular communication, where you are moving towards an ITS, that is Intelligent Transport System, and we are moving towards the autonomous vehicles. So today my presentation is with respect to the vehicular communication and its advancements and a few research problems, so that you people, those who are interested in 5G communication, they can concentrate on the research problems and they can find different solutions. There are so many organizations in the world who are still working on the vehicular communications. And to be frank, right now we people are surprised to see that we are moving towards the electrical vehicles, and we too know that electrical vehicles are already on roads in India. But a lot of research, more than the electrical vehicles, are already existing, and most of the people are working towards the autonomous vehicles. So few people think that autonomous vehicle means a vehicle with no manpower. But the basic statement of autonomous vehicle is completely wrong. An autonomous vehicle is equipped with so many sensors in order to justify itself while moving on roads. especially with respect to such type of highly populated India and China. We always, it's a great challenge to the researchers to provide such type of autonomous vehicles. So, so you can see here from the second slide, please. Yeah, okay. I can change. So you can see from this, you can see from the diagram that there is a vehicle and there are so many electronic devices by which your vehicle can communicate. The modern 5G communication has given a wide scope for the vehicular communication, not only to communicate between vehicle to vehicle, but it can also communicate between vehicle to all other devices. So especially under the 5G, there are so many applications like your cooperative communication, green communication, vehicular communication, and even your cellular communication. Now they are a part of 5G. So we people basically think that when it is termed as 5G, we think of only cellular communication and the communication what we are receiving with respect to our mobile. But 5G is not defined only for cellular communication. There are so many other wings in which the 5G is supporting. Now out of which, why we are concentrating on the vehicular communication is to exchange our information from vehicles, from vehicle to the roadside units and other networks with the pedestrians, with the even traffic lights, so that we have a significant information from the surroundings so that all the safety measures in the transporting system can be implemented. So these are the few things that has to be concentrated when we are going for the vehicular communication. Initially, vehicular communication was only designed to provide safety measures to the end user. Means when we are driving a car, there are so many difficulties with respect to the human beings. There are so many human errors which can lead to so many accidents. And right now, if you go into the metropolitan cities, one of the major problem is traffic and congestion. To avoid such type of congestions, to avoid even accidents, to have a safety measures, to have a automatic brake systems, so vehicular communication was intended to provide all such type of services under 5G. Especially we can find any type of stationary vehicle warnings, your intersection collision warnings, so your signal facing and timings, your road user protections, your electronic braking system, your traffic light turning on and off risk warnings. So generally for a vehicle what you observe is, suppose I will give you an example. If I am moving from Tarnaka to something like Secunderabad, I don't know what is the exact traffic congestion in the Secunderabad, and I may take that route by which I may have certain delay in reaching my organization. Now this vehicular communication is not only used to provide security but also provides certain type of informations by data acquisition. So one of the major thing is whenever a existing technology has to develop, then it has to adapt to its emerging technology. So one thing is right now you people, I'll give you a best example while explaining the topic. So right now you people are holding 5G mobiles. I think almost every human being right now they are holding a 5G mobiles, but it is still compatible to the 4G. If you are holding a 4G mobile, then still it is compatible to the 3G. Now whenever an engineer or researcher thinks to develop a particular standard, then he always designs in such a way that it should have a compatibility to the existing system and also go with the new things. So one is supporting the emerging use cases, and second one is providing interoperability, and next one is specifying the minimum requirements. So whenever an engineer or a researcher is going to find any new thing, then one thing what I have said is it has to be compatible with the existing one, and it has to be interoperable, means it has to be compatible to the other systems. Now you cannot design a vehicle where a vehicle can only communicate with a vehicle. You can understand a small thing. You are holding a mobile, and mobile initially was developed only for voice communication. But right now, in fact, the existing technology says that you are not holding a mobile, you are holding a computer, because you can do all the operations of computer in the mobile. Your mobile is able to provide near-end communications. Your mobile is able to provide your internet access. Okay, you have a Bluetooth, so you have certain type of applications. So rather than voice communication, you extended the same mobile to multiple other operations. Similarly, here the basic concept is not only to provide vehicle to vehicle communication, but also to support other activities. Your car should be connected to a Wi-Fi network. Your car should be connected to a cellular network. Your car should be connected to all the heterogeneous networks which are available in the market. Similarly, providing the minimum requirements. See, no organization tries to completely go with the almost from the base. From the scrap, it cannot go for an implementation. So existing architectures should be used for the new developments. I can give you one more example with the same thing. So whatever the base stations, your cell towers you are observing in the general market, those cell stations, your base stations are not modified. The same base stations are used, but we are able to get our 5G. So this provides that for any vendor who is providing such type of service, he always tries to implement developments only on the existing system. So right now, I can give you one more example. So here you can see a vehicle, a car, in which you can find so many type of electronic devices. So earlier we used to have a car which is only having a steering and other brake systems. But right now the modern vehicles, you might be observing that it has an automatic brake system. Okay, it has some front end camera, a back end camera. From this diagram, you can clearly observe that autonomous vehicle has so many type of electronic devices. A few things I would like to mention. One is your long range radar, okay, short range radars, your mid range radars, front side cameras, okay. You can have your localization by using your GPS. So many electronic devices which help for the navigation, which help for the security are embedded into today's vehicle. Now when you are going with an embedding term, then it becomes difficulty for an engineer how to collaborate the two different networks, two different organizations. Now this is a simple example how the modern 5G communication is explaining a vehicular communication and the minimum requirements for a vehicle to be a part of 5G. Now you can see most people generally, especially the students who are going with the final years and PG programs and researchers, they are very much familiar with the vehicular communication. But there are so many technical terms which are right now into the vehicular communication. From ground, if I say, the first implementation is DSRC. Okay, I will give you a clear explanation of all these terminologies and their specifications. Later, because of the requirements, they moved to the wave. And again, finding this wave only limited to the 4G communication, they reached to CV2X. And the C stands for cellular vehicle communication. So embedding the cellular communication into vehicular communication is called as CV2X. And later now, after the implementation of 5G in the world, now it is newly termed as 5G NR V2X. 5G NR stands for the new radio V2X. So now these are the different stages, revolutions which are already existing with respect to the vehicular communication. Most of the research is concentrating on CV2X and 5G NR V2X. And DSRC and Wave, they are still existing, but it is already a standardized technology and it has its own limitation with respect to networking. So this is how the DSRC represents. A DSRC is, it's a short range communication where you will be having maximum of only 1 kilometer of dimension. The coverage area of the vehicle can be of only 1 kilometer. It's a short range communication. And the spectrum which is provided for vehicular communication under DSRC is 5.8 to 5.9 gigahertz and it is ranging around 75 megahertz of bandwidth. So as you people know that the bandwidths for any organization will be given by Federal Communication Committee. So FCC has allocated 5.9 gigahertz to the DSRC. So it is used to provide both public safety and also your private operations. Okay, whereas this particular technology has a limitation that it can provide only two services. One is vehicle to vehicle and another one is vehicle to infrastructure communication. Because of this limitation, it has moved towards the wave and further other evolutions. Now here you can see that why this DSRC is basically implemented and why it is called the initial technology with respect to vehicular communication. So the basic intention of vehicular communication is safety and the second one is vehicle to vehicle communication. As said here, you can see that it's a two-way communication, full duplex, where it only supports up to 1000 meters, that is equal to 1 kilometer. And as I already said that it is 5.9 gigahertz spectrum, and whereas the upper layers and the security layers of IEEE 1609 are standardized for this DSRC. Now it can also have a collaboration with Wi-Fi. Yeah, you can say that DSRC is Wi-Fi based technology, and the protocol which is used by is 802.11p, and which is basically a revolution with respect to the physical layer and the MAC layer. And here the latency with respect to the DSRC is somewhat low, and but it is not matching to that of your cellular communication. Now the next one is a small improvement with respect to the DSRC is Wave standard, which stands for the wireless access in vehicular environment. Now this has concentrated mainly on upper layers and a slight modification with respect to SAE international standards, and SAE stands for Society of Automotive Engineers. Now what are the basic challenges? Basically, when a vehicular communication is implemented, we need to find the congestion, because more vehicles are already in the existence. There is always a channel congestion. Channel congestion means a multiple vehicles, if they are utilizing the same channel at the same time, then it leads to congestion. So one of the basic problem, because of the limitation of the bandwidth, the DSRC is having a channel congestion problem. Second one is lack of handshaking and acknowledgements in delivering the broadcasting frames. So here I think most of you people know the basic communication technology, how the communication is done. So this particular DSRC is not providing any type of feedback from the other end user. So once if you don't have the feedback, then automatically it is nothing but a centralized control system, not a distributed control system. So this leads to a lot of problems with respect to safety measures of the vehicle. And next one is self-interference due to inadequate spectrum masking. So here 5.9 gigahertz is specified, and only 75 megahertz of bandwidth is provided. By using the FDD, again it splits, if it is splitted, it will come around 35 megahertz, which is very small for full duplex communication, so it leads to self-interference. Especially by this time, I think you people know that the basic problem of full duplex communication is loop interference, yeah, we call it as self-interference. Next one is no quality of service support, because once there is no handshaking or acknowledgement, the quality of service required by a specific user, yeah, specific vehicle is not specified in this particular specification. And there is no internet connectivity, because especially the limitation of this technology is only 1 kilometer, so it cannot directly connect to the cellular network or any other cloud-based networks by which it can have cloud facilities or internet facilities. So if we go with such type of limitations, the next generation DSRC, which we call it as Wave, has introduced a new specification that is called as 802.11 BD. It is a new technology, it is almost competing with the LTE, again V2X. So where you can find that there are certain modifications, certain changes with respect to 802.11p. I'll give in the next slide. So here you can see that 802.11p, which we call it as DSRC, was basically using only OFDM with respect to 10 megahertz channel bandwidth and 8 modulation and coding schemes. And this was the implementation with respect to the physical layer, and because based upon higher modulation techniques, the maximum data rate that was achievable was only 27 Mbps. Whereas if you go with the 802.11 BDS, now it has provided a new particular frame structures, variable frame structures with respect to the MAC, and the physical layer implementation with respect to the predecessor. And here you can find that the maximum speed that can be supported by 802.11 BD is of 500 kilometers per hour. Now these are the few differences, few features of 802.11p and 802.11 BD, where one of the major thing that is supported is difference is 802.11 is able to support only 252 kilometers per hour, whereas 802.11 is BD is providing 500 kilometers per hour. The subcarriers which are used earlier were only 10 subcarriers, whereas here we can use multiple subcarriers. And the type of channel coding which we are using is LDPC, low density parity coding. So which is one of the new convolutional code which is always already proved successful for many wireless technologies. Now other than the 5.9 gigahertz, it is also providing one more, that is 60 gigahertz, because of which the bandwidth limitations few bandwidth limitations are overcome with the help of 802.11 BD. A new concept, a cellular concept which is also included with respect to vehicular communication is cooperative vehicular communication. So this cooperative represents a green communication where you can understand that the vehicles can cooperate with one another and share their information so that all the safety measures and the data transmission can be done. So from this diagram, it is clearly visible that there are few different type of cooperative V2V communications, where you can see from the first diagram, that is A, the vehicle assisted cooperative V2V, and the second one is vehicle assisted cooperative V2V. But here first one is there is no centralized RSU unit, roadside unit. In the second one you can find that RSU unit. Now you can observe from this one, there is a source in the first diagram, there is a destination, and the middle vehicle is acting as a relay. This concept is already proved to be a predominant one with respect to cellular communication, and towards 6G we are going for cooperative communications. The same thing is already implemented with respect to vehicular, where the neighboring vehicles will support the source vehicle to transmit information. So this not only reduces the transmitting power of the source vehicle, but also we have certain type of redundancy in receiving the data. So rather than receiving the data one time, the destination vehicle will be receiving the data multiple times. So multiple reception always decreases the bit error rate, and it always provides the redundancy. Whereas we find in the second diagram that the roadside unit, what we call it as, you people can call it as a base stations. So the roadside unit will help us in order to provide cooperation between two vehicles. From the second diagram you can see that rather than another vehicle, a neighboring vehicle, the roadside unit is cooperating so that the source can transmit the information to the destination. Now once the roadside unit we implement with cooperation with respect to the roadside unit, there are a lot of benefits, because in the first diagram you can see that all the vehicles are moving. They will be having their own velocity. The topology might be same, but they are in moving condition. So the topologies are dynamic with respect to the second diagram. So there is a lot of complexity in designing such type of system rather than going with the second one. In the roadside unit, the base station is stationary, so the intermediate vehicle don't have any velocity. So it reduces the complexity of networking. So if you go with the third diagram here, again when it leads to the cooperation is not only with respect to vehicles but also with respect to the roadside units. This sort of communication is especially helpful when vehicles are moving on the highways, because in cities you find these roadside units, but when we are going on the highways, then hardly we find such type of base stations. Now as we cannot provide such type of cooperation for high moving vehicles, so we are taking the help of roadside units, and the cooperation is developed not only with respect to vehicles but also with respect to the roadside unit. This will help to have a continuous reliability and link connectivity between the vehicles and the roadside unit. So one of the basic technology which the cooperative communication is implementing is NOMA. As I can see that most of the participants are also students, you people are most familiar with orthogonal multiple access. Yeah, you can even call it as OFDM. So OFDM has so many limitations when it is coming to the 5G communication. So rather than using OFDM, right now the new technology which is implemented is NOMA. This is non-orthogonal multiple access. So this is not going to have, this is not going to have an embedded with TDD or FDD. It has its unique feature with respect to its implementation. Now the bandwidth is not going to be shared with respect to the all other. So the bandwidth used for this NOMA technology will be same for every users. And as you people know that if the bandwidth is large, then the capacity will be large, then automatically the data rates will be large. So in order to have this basic benefit of using the larger bandwidths, NOMA is basically implemented with complete bandwidth to each users. Then the question comes is, what about the interference and how you are going to support for multiple users? NOMA is basically designed with respect to two features. One is power domain NOMA, another one is code domain NOMA. And most successful one is power domain NOMA. So here the new technology leverages a new improvements with respect to spectral efficiency, because multiple number of users can use the same bandwidth. So bandwidth is not going to be wasted with respect to an individual user. Next, as it is supporting multiple users, you can have the massive connectivity and interference cancellation with respect to successive interference cancellation technique. And link reliability is more because the NOMA is specially designed for the cell end users basically. So which also provides a cooperation by which the link reliability is always sustained and reduced transmission delays. So specification says that the NOMA will not introduce any transmission delay, but the cooperative communication also includes some transmission delay. Okay. Now this is a small presentation in which you can observe the difference between an OFDM and NOMA. Now how the bandwidth is split among the multiple users, you can find different colors with respect to the diagram, where different color represents different user allocations. Whereas if you see the NOMA, the different users, multiple users are using the same bandwidth, same subchannel. Now these are the different things where most researchers are concentrating. So you can find from this table that it is the few people are concentrating on impact of the path losses, few are concentrating on the integration of cooperative networking with respect to NOMA, NOMA with respect to the MIMO implementation and the beamforming, NOMA in the coordinating systems, and NOMA user pairings, and NOMA light communication. And when it comes to any wireless communication, basically we have so many problems. One is with respect to pairing, one is with respect to clustering, interference, resource allocation, using of multiple antennas. Right now we are in the technology of large antennas, so using multiple antennas, and by that we are going to evaluate the system by using your outage probabilities, throughputs. In the same way, we are going to calculate the errors with respect to the signal transmissions, signal processing overheads, and the limitations in the end users. So this diagram will not only explain what exactly the work is done under the NOMA, but also the different areas where the researchers are concentrating in the world. Now this is a diagram which basically specifies how the NOMA is implemented with respect to two end users. So you can observe that from this diagram you can observe that I have a roadside unit, what you people basically call it as a base station. You can find that user B is very near to the base station, whereas user A is far away from the base station. Now here we are going to use the successive interference cancellation at the user B, which is very near to the NOMA, very near to the base station. Now the information when it is transmitted, now it is broadcasted to the user B and also user A. Now when the information is transmitted, it is in a different format by using the superposition coding. Now where the integration of the two user data is integrated with respect to one technique and transmitted to all the users. Now each end user can decode the information by using SIC and again can retransmit to the for end users. Now from this diagram you can see that user B has received the complete information, user A information and user B information. User A is also receiving the same information. Now from this diagram you can observe that the user B is using a successive interference cancellation so that it can subtract the information of user B and retransmit the information of user A. From the end user A, you can observe that the user A is going to get the information twice, one directly from the roadside unit, another with respect to the user B. Now here the interference is reduced by using successive interference cancellation with respect to the user B. And if I explain with respect to the power domain NOMA, the end user B, which is very near to the base station, will be having low power, whereas the power allocation to the user A, which is far away from the base station, will be having the high power. Now here the differentiation is with respect to successive interference cancellation and the power allocation. As we are differentiating with respect to power, it is called as power domain NOMA. A simple thing I want to say is the far end user will always have low received signals. In order to overcome such type of problems, in order to mitigate the interferences, then the far end user is provided with maximum power, whereas the near end user is provided with very low power. So there are so many, again, researchers have proposed different types of logics for this. Whether the power allocation coefficient is constant, yeah, it is different. So we can find that the power allocation coefficient should be calculated based upon the relative velocity between the two vehicles. So here you can see that the allocation of the power for user A and user B is always related to the relative velocity between these two vehicles. The same thing I have projected with respect to the uplink transmission and the downlink transmission, and also in order to differentiate between OMA. Now here also the same thing what I have already explained is with respect to the downlink. For the uplink also you can observe that from this one second diagram of the left side, you can observe that two mobiles, you can call it as a mobile, yeah, you can call it as a vehicle, whatever the technology I am explaining, which is with respect to the uplink, where the two end users are able to transmit with respect to their channel coefficients to the base station, yeah, to the roadside unit. Now here, as the user 1 signal will be received with high received voltage, the user 2 data will be almost compensated because user 1 information is going to dominate the user 2. Now, in order to have a power difference with respect to the received signals, successive interference cancellation is used at the base station. The near end user information is subtracted and it is again used as a reference to the user 2 so that the bit error rate of the user 2 can be reduced. The topic is the content, yeah, the concept with respect to the uplink and the downlink are same, but the successive interference cancellation implementation at end user, implementation at the roadside unit are completely different. Now you can observe one of the simulation result where we are going to compare the channel capacity for the uplink and downlink with respect to AWGN channel for the NOMA and also for orthogonal multiple axis. For the in the first diagram, you can observe that, okay, so the NOMA is providing better data rates compared to that of orthogonal multiple axis technique. Whereas for the second user, you can observe that NOMA is providing more data rates compared to the first one. The difference between these two is only the end user. So here, the only with respect to the cooperative end users. This simplifies that NOMA is able to provide a better data rate by compensating the interference with successive interference cancellation. So the new technology with respect to the vehicular communication is cellular technologies. So cellular communication, what we are regularly using is integrated with vehicular communication and we are calling it as CV2X. V2X stands for vehicle to any. That X can be a vehicle, that X can be a cellular network, the X can be a pedestrian, the X can be a roadside unit. So here a vehicle has to communicate to whatever the existing technologies available in the market. So right now we can easily define this one as a heterogeneous communication. Okay, so this is also specified by 3GPP. We call it as third generation partnership project. This particular organization is giving the specifications for all the communications. So the release 14 was specially specified for the CV2X and it has specified that LTE, long-term evolution technology, can be integrated with V2X. And I think by this you people know that long-term evolution is nothing but a 4G. So CV2X is a technology under vehicular communication which supports only 4G communication. So LTE V2X is basically designed with the concept of device to device communication and the interference side-link interface is basically defined with PC5. I think by this time you people might have studied different types of interfaces. So this is an interface PC5 which is basically used between vehicle to vehicle communication. Now this interface, with the help of this interface and the different type of physical parameters, the high mobility of the vehicular environment can also be supported and a different type of demodulation with respect to the reference symbol, that is nothing but DMRC, is also used in order to demodulate your signal. This not only demodulates but also reduces the effect of the Doppler effect. Why the Doppler effect concept is coming into this is Doppler effect is basically depend upon the relative velocity. Whether the vehicle is moving away, your vehicle is moving coming near to our vehicle, it also increases the Doppler frequency. So the Doppler effect has to be compensated when we are going with the vehicular communication, and this can be done by using DMRC. So there are two different types of modes which are specified under LTE V2X. One is mode 3, another one is mode 4. So mode 3 and mode 4. So these are the some of the different challenges with respect to the CV2X, where high relative speeds leads to different Doppler shifts. As I already said that it is going to compensate, but the Doppler effect is not nullified here. So that is one of the problems still existing, and because of this Doppler shift we do have a problem of frequency offset. Okay, whereas the C2VX has already improved, but with synchronization and the channel estimation. And by this time, I think you people know that channel estimation is always one of the eminent research problem which is still under research. Most of the people, they concentrate with respect to channel estimation. When especially it comes to the wireless communications, the channel estimation is one of the critical problem that has to be estimated prior to that of going for decoding. Second one is high mode density. This is one of the challenge which was from the initial stage of vehicular communication, where you can find that different vehicles are moving in the different directions with different topologies. Now this can be overcome by using a transmit, control and data on the same subframe so that it comes under the in-band communications. Second is more proper resource allocations and sensing of different parameters with respect to the resource allocations will be helpful to overcome this challenge. Next one is time synchronization, because as I am saying that we need to, when we are connecting to the different organizations or communication networks, the timing, the synchronization will be different. Like you can observe from this diagram that cellular communication uses a different frame format, different time synchronizations, whereas vehicular uses different time synchronizations. Now if you are going to have an collaboration between these two networks, then the time synchronization should be matched. So this is one of the problem. And basically, when you are connecting with respect to any type of vehicle, we need to know the exact location of such type of device. So one of the device which is embedded into the vehicular communication is your GPS. Now when it is an heterogeneous communication, rather than its individual timing synchronization, it uses GPS timing synchronization. So which is a third party for our vehicular communication. So there are certain advantages with respect to the cellular V2X. One is we are using the existing cellular architecture. So for any vendor, the implementation cost, the installation cost will be less. That is one thing. And cellular communication is already well established, and we know the pros and cons of the cellular communication. So already the lot of research has been done, so which will be helpful for the implementation of our vehicular communication. So the roadmap of even the cellular 5G is already fixed. So it is, when the specifications are well known to the researchers, it becomes easy to integrate a new technology to the cellular communication. And it is also generated or developed by 3GPP2. So already the 3GPP2 has given the 5G and 6G specifications. So integrating these two technologies will be most compatible and easy. Now this cellular V2X has provided high connectivity, high reliability and low latency with respect to vehicular communication. So because of which we are able to connect very high speed networks. So these are the few advantages of using cellular network with respect to the vehicular communication. Now already I explained about the DSRC and also with respect to CV2X. So this presentation gives you the major difference, specification differences between DSRC and R14. Now you can observe that advanced channel estimations are basically used in the DSRC, which leads to the complexity at the receiver, whereas nominal channel estimation is more than sufficient for CV2X, because already the channel estimation process is done with respect to the cellular networks. So in the DSRC we will be using only the TDM, whereas we will be using an integration of the TDM and FDM. And you can find that the turbo coding are also used in the conventional coding, and we are using single carrier FDM rather than using an OFDM. So already specified NOMA technology with respect to vehicular communication. One more technology which is basically used under the physical layer is single carrier FDM technology. Now you can see from this simulation result, the basic performance with respect to attenuation and with respect to the packet error rate. You can observe that CV2X, though the signal attenuation is more, you can observe that the PER is gradually less. Now from this what you can say that because of the integration of the cellular networks with vehicular networks, so it becomes very easy to provide continuous link reliability, and as the latency is low, which is also going to affect your packet error rate. So the next new technology to overcome the limitations of CV2X is new radio CV2X, which is introduced as a complementary for CV2X technology. So this is a slight modification with respect to the CV2X. The new radio represents the new bandwidths that are allocated to the existing CV2X technology. This is a new release with respect to release number 15 and release number 16. So basically CV2X or LTE-V2X was only used to provide broadcast communication, whereas your NR-V2X is able to provide broadcast, group cast and also unicast type of communications. So the different sensors which are introduced with respect to the NR-CV2X, okay, almost 50% of the new sensors are introduced in NR-C2X, and these sensors and the integration of their data with respect to the neighboring vehicles are only possible when you are dealing with respect to the group cast and unicast. This is one more diagram where you can observe that NR-C2X is not only supporting the LTE-CV2X, but it has to concentrate on both things. One is safety cases, another one is advanced user cases. Advanced user cases always deals with respect to upper layers of generally protocols, whereas the safety measures are included with respect to the physical layer. Now here, release 16 plus are also helpful in providing such type of advanced specifications. Advanced in the sense, for any layman I can say that advances with respect to vehicular communication means not only going with the safety measures of a vehicle, but also providing data communication and high-speed data communication to even end users. So when I specify with respect to vehicular communication, first application is safety application, second is intercommunication between the vehicles, whereas third one is providing entertainment or high data rate communication, so that an end user who is sitting in a car can also have an internet access on his vehicle. So all these are possible with the help of new radio CV2X. Now all these facilities are only possible with the utilization of flexible framework. Now if you observe the most of the communications, we always have a fixed frame size, but whereas here in the NR CV2X communication, it is going with the flexible framework by allocating a scalable OFDM technology, by allocating the scalable slot based frameworks, and by using the different channel codings. You can observe the most of the wireless communications, they fix to only one type of channel coding, one type of convolution coding, but based upon the quality of service requirement of the end vehicle, the channel coding the convolution coding can modify as per the requirement. So next one is slot allocation, which comes as a resource allocation. Now I already said that earlier normal CV2X was using around 50 to 20 subchannels, whereas here based upon the requirement of the vehicle, the number of subchannels can be increased. So here the leverages to the LTE CV2X concept, as already told that NR is a new concept of an extension of LTE CV2X, so it has to be compatible with even LTE. So the new compatibility includes connections on the fly distance based grouping. So this distance based grouping is a new terminology, but the basic concept of this one is only clustering. Based upon certain metrics between the vehicles, the clustering is formed, and rather than going for the relay identification, we will be identifying the cluster head, which will be acting as a master to the complete cluster, and this reduces the complexity and also reduces the latency when we are going with the cooperative vehicular communications. So the major performance improvements, as I said, that it is going to lower the latency, high spectrum efficiency because we are using the clustering mechanism, and high capacity because of the cooperativeness. So now this diagram also shows the extension of this one, why we are going with the high spectrum efficiency, because when we go with the NOMA technology, the complete bandwidth can be utilized by multiple users, so spectrum efficiency increases. Rather than providing individual frequency to individual users, all the complete bandwidth will be provided to all users. and the channel spacing between the different subcarriers is also reduced, so that more number of subcarriers can be used and the interference can be compensated by using successive interference cancellation under NOMA. So the same thing which I am again going regarding the latency, you can see that the latency can be reduced up to 1.5 milliseconds, and the packet scheduling and the data rates can be almost doubled with respect to the NR-CV2X. A simple concept with respect to NR is additional bandwidth is provided in order to accommodate more number of end user services. So you can see these are the things, the same scalable OFDM, self-contained slot allocations as per the requirement of quality of service, different type of channel codings, the wideband carrier supports, because here we have a carrier aggregation which is a part of our 5G, where multiple subcarriers can be aggregated based upon the quality of service, and using of the multiple antennas. As a vehicle don't have any energy constraint, as it is self-driven energy vehicle, so we can use multiple antennas. So rather than going with the single antenna, large antennas are also equipped for the vehicular communications. So which further leads to the high throughputs, high speed performance, application awareness based upon the adjacent vehicles, background compatibility and high reliability, so that the communication can be smooth among the vehicles. Now this shows the features difference between LTE and NR-V2X, where as said that the subcarrier spacing used for the LTE is only 15 kilohertz, whereas based upon the quality of service, it can vary from 15 to 120 kilohertz. And the communication modes, as I explained, the LTE only supports broadcast, whereas NR-V2X supports unicast, groupcast and also broadcast. So the modulations 16 QM is the highest modulation which can be used for LTE, whereas here we can move up to 64 QM. And OFDM in parallel with the NOMA is also implemented for the NR-V2X. So there is a slot flexibility because of the DMRS already explained. So the number of subframes that can be used for larger transmissions can vary based upon the end user capabilities. And the LTE specifies mode 3 and mode 4, whereas NR-V2X specifies mode 1 and mode 2, which are basically related to the group casting and broadcasting. So here are some of the key challenges with respect to vehicular communication. One is network scalability and capacity. Network scalability always leads to the providing the scalability to the network to provide the end user demands. So as we are moving from one generation to another generation, our requirements will gradually grow, and the network has to support our new requirements and has to satisfy the end user. And the second challenge is low latency and high reliability. So for any communication, wireless communication, one of the important parameters is low latency, because especially when the vehicles are moving with high speeds, this low latency plays a major role. And especially for the urban areas where the traffic density is very high, the latency plays a major role. Now a vehicle has to have the knowledge of nearby vehicles, and based upon their relative velocity, their position, it has to take the decision either to slow its speed, or move to the right side, or move to the left side. The decision can be only made with respect to such type of low latencies. And the next one is security and privacy. So basically most of the CSC researchers under computer science, they deal with the security and privacy, because it is using 5.9 gigahertz, and as the vehicles are completely independent bodies, there is always a chance that your information can be captured by some third user. So next one is spectrum allocation and interference. So spectrum allocation and interference is always a major problem for every wireless communication. Even though the bandwidth is increased, as the number of end user requirements are increasing, the spectrum allocation is always a difficult task. And you can also find that the number of vehicles in India are almost growing at the rate of 50. So number of vehicles in the sense the cars, what I am saying. So more number of vehicles, when they are using this vehicular communication, the spectrum efficiency is going to decrease. And then that leads to your interference. And next one is integration with the emerging technologies. I've already said that we are moving towards the heterogeneous communications. Your vehicular communication should be adaptable to your cellular, should be adaptable to your roadside units, should be adaptable to your cloud networks. So it has to integrate with all the emerging technologies in the world. So Again, I have explained the different type of challenges with respect to individual research challenges. One is network scalability and capacity. Network slicing is one of the new technology where you can move from one particular network allocation, you have one frequency to another frequency, you have one network to another network based upon your requirements. So once the network is silent, your network is not usable, then any other network can utilize that, and this is a part of basically implementation of cognitive radio. Next one is edge computing for low latency and data processing. So this is based upon your signal processing application where the significance is highly given to reduce the latency, and this is based upon the cloud computing technology. Next one is adaptive modulation and coding. So here the modulation can be of your 16 QAM, can be of your 32 or 64 or 256 based upon the requirements of data transfer or throughput. Second one is low latency and high reliability. This can be achieved by using your URLLC, by which you can have your hybrid acknowledgement. Multi-connectivity and redundancy, it will also reduce the low latency and high reliability because the information is not only received from one end user, but it can be improved, and the reliability can be improved by using the redundant of the data. And cooperative communication techniques already explained, that is using the other vehicles as an intermediate relays and propagating the information with the help of the relays will always helps in providing the reliability. In the DSRC, the maximum coverage was only 1 kilometer, whereas for NR V2X, the maximum coverage is unlimited. Security and privacy, which is out of the scope. Next one is spectrum allocation and interference. So we can allocate the spectrum dynamically by sharing mechanism. We can use the cognitive radio, as I said, that any unused frequency band can be allocated based upon the quality of service requirement. Next one is beamforming, which is a part of your multiple antennas, where you can also have a interference mitigation by using the beamforming. Integration with emerging technologies, as already said, that cooperative communication has come into existence. 5G NR has to go with the LTE V2X, and V2X should again go with the different type of communications which are already existing in the market. And if you go with the future directions, there are so many problems because the vehicular communication is still not evolved in our general life. Now still you can find electrical vehicles, but in India we are unable to provide such type of vehicular communications because of the high dense population. The density of vehicles with respect to India, if you see for the foreign countries, so because of low vehicles we have certain problems, because of high dense vehicles we have so many problems. Especially connecting two different autonomous bodies is always a big challenge for any type of wireless communication. And if you see that vehicles, if you generally observe the vehicles, we have different topologies, different routes, and different safety measures which are included in the vehicular communication. Bandwidth is one of the challenge, low latency is one of the challenge, link reliability and link adaptation are the few major challenges with respect to vehicular communication. So most of the researchers, they are concentrating on these things and moving towards the 6G. So the different companies still they are working for the vehicular communication is MIT, okay, California, Mellon University, and Qualcomm, AT&T. Qualcomm has already released different specifications with respect to the 5G NR, Ericsson and Nokia. So today my presentation has given an insight about what is a vehicular communication, and for most of the participants it has given what are the terminologies with respect to the vehicular communication from DSRC to 5G NR. Thank you one and all. I request the participants, if you have any queries related to this topic, any interest related to this topic, you can ask me. I think most of you are very familiar with the cellular communication. So one small thing before concluding, I can say that you are holding a mobile, you are moving here and there in the campus, on roads, in-house, but still you are continuously getting a signal and you are able to do your calls. Okay, the same application is given to vehicles. Rather than your mobile, the end device here is vehicle. The vehicle also can move in any direction, but still can be connected to any one of the network. This simple resolution has brought to a new technology that is called as vehicular communication. Whatever the problems you have with respect to mobile communication, the same problems also exist for vehicular communication. But one thing is, here vehicles don't move as we move our mobiles. We suddenly move from one place to another place, from one room to another room, but vehicles don't move in such a way. Vehicles always move with respect to a topology. Means that is, we have a predominant roads, we have particular directions of moving. So the movement of the vehicles here, the trajectory of the vehicles will be always easy compared to that of mobile communication. So this is the new advancement with respect to the 5G and 6G, and I think it hardly takes around 10 years for India to implement such type of vehicular communication only because of its high population.
It's a release 14, you said.
Release 14 with respect to CV2X, sir. Right now, the new terminology is release 15 with respect to 5G NR CV2X.
Any mobility difference between both?
Yes, sir. For CV2X, it was supporting only 250 kilometers per hour, whereas for NR, it is supporting around 500 kilometers per hour. So, which also supports not only rural traffic, but also urban traffics, and even it is supported to the highway scenarios, where the vehicle speed will be very large. If no queries, thank you everyone.
Thank you, sir, for your wonderful lecture. I also thank the audience for attending this session. And I request all the authors and participants to join in their respective tracks according to the schedule given. I request Dr. M. Raju, sir, HOD ECE, and Dr. B. Ramadevi, madam, Conference Chair and Convener IC3T 2023, and Professor G. Raghutam Reddy, sir, and Dr. V. Venkateshwar Reddy, sir, to join our HOD and madam to present a memento to Sushant Babu, sir. All the faculty of ECE are requested to join.
All of you join, that side join. Students, please join.
Thanks a lot. Thank you, Professor. Thanks.
Thank you, sir, for your words of wisdom. It is an honor to have you here. I invite all the dignitaries, Professor K. Ashwaka Reddy Garu, Conference Chair IC3T 2023, Chief Guest Professor K. V. Sridhar Garu, Dr. M. Raju, sir, Program Chair, Dr. B. Ramadevi, Conference Chair and Convener, Dr. K. Ramadu and Dr. K. Saujanya, Coordinators, and Mukim, sir, and C. H. Pawan, sir, Co-Coordinators, to please grace the dais. I also welcome Rohit Sanam Venkata, Workshop Faculty, Data Vision AI CEO, to please grace the dais. Today, we gather here to celebrate the culmination of a journey that has been marked by hard work, dedication, and a pursuit of knowledge. The International Conference on Computers and Communication Technologies 2023 has been an event of immense importance for all of us. And as we stand on the threshold of our valedictory ceremony, it is an honor to address this distinguished gathering.
First and foremost, I would like to extend my heartfelt gratitude to the chairman of our institution, Captain Lakshmikanta Rao Garu, ex-MP Rajya Sabha, whose visionary leadership has been instrumental in making IC3T 2023 a resounding success. Your unwavering support for academic excellence and quality education has laid the foundation for the success of this conference. We are forever grateful for your guidance and encouragement, sir. To our treasurer, Sri Narayan Reddy Garu, for constantly motivating us and supporting us all the time. Sir, we are forever grateful for your guidance and encouragement.
May I now call upon the guest of honor for this valedictory ceremony, the workshop faculty, Rohit Sanam Venkata, to please address this gathering.
Yeah, thank you everyone. I would like to first thank Professor Ashok Reddy sir, Rama Devi ma'am, Raju sir, and other faculty members of EC department, and also conveners and coordinators of IC3T International Conference of Communication and Computer Technologies for giving me this opportunity to talk about artificial intelligence and machine learning and give a confidence to the students that artificial intelligence and machine learning is not a rocket science, because nowadays students, to take artificial intelligence and machine learning as their major, they are getting scared because of programming. But I gave a confidence to the students of Kakatiya Institute of Technology and Science, Warangal, especially the ECE students who has attended my workshop, that any person from any background can make a successful career transition towards data science. And being a person from a non-technical background from ECE, I have made a successful career transition from data science. And when it comes to my profile, I have completed my bachelor's in electronics and communication engineering from Usmania University, that is Mufakamja College of Engineering and Technology. And after that, I have completed my master's in Manipal in data science and a PG certification in data science from IIT Guwahati, and an executive MBA in business analytics from Indian School of Business. And also, apart from that, I have also completed 27 certifications in data science. But this is why I'm telling this is I'm not boasting of myself, but my main thing which I want to convey is that any person from any background can make a successful career towards data science and artificial intelligence. Thank you.
Thank you, sir. We greatly think that your workshop have helped our EC students master their career towards data science. I also want to acknowledge the tireless efforts of the convener of International Conference for Communications and Computer Technology 2023, Dr. B. Ramadevi Garu, Professor, Department of ECE, who has worked relentlessly to bring this conference to life. Your dedication, attention to detail, and leadership have been exemplary, ma'am. Now I request Dr. Ramadevi ma'am to please brief the gathering with the report of IC3T 2023.
Good evening to you all. Good evening to you all. With the support and blessings of Erragattu Venkateshwara Swami and elders, our beloved chairman, Captain V. Lakshmikant Rao Garu, Treasurer Sri Narayan Reddy sir, we start our valedictory. Dignitaries on the dais, beloved Principal Professor K. Ashok Reddy sir, Chief Guest Professor K. Sridhar sir from NIT Warangal, Guest of Honor Rohit Sanam Venkat, CEO of Vision.ai, our dynamic head Dr. M. Raju sir, IC3T coordinators who are the backbone of this particular program, Dr. K. Ramadu and Dr. K. Saujanya, and coordinators CH Pavan and Mukim, and my department faculty and staff and students and participants, a warm welcome to you to the valedictory of IC3T 2023. We successfully completed all the tracks with the support of all my session chairs, faculty coordinators, ECE department faculty and staff, and student organizers. Workshop on AI went on well. Hope my student team experienced the AI fundamentals and programming concepts and implementation of neural network. I think Rohit given some AI based application developments. I thank all the participants, authors for participating this event with great enthusiasm. Special thanks to management, principal for giving necessary approvals and support. I especially thank Springer and the editor Springer who given approvals for 2 volumes for this particular conference. A heartfelt thanks to my friend Dr. K. Srujanraju and his team for their wonderful support to IC3T 2023. We thank to Professor Mantini Seladurai Madam, HW University UK, Professor T. Kishore Kumar Sir, who accepted our invitation as keynote speakers, as well as the guests of honors and editors for IC3T 2023. We're really thankful to both of them and all my editors of IC3T 2023. I thank Rohit Sanam Venkat, CEO of DataVision.ai, for his support to the workshop. Very special thanks to all my Department of ECE faculty and students, and special thanks to all my session chairs of the institute, Kids Warangal and other institute friends who acted as session chairs, and faculty coordinators and students team. This is a point actually I want to mention in Telugu. స్టూడెంట్స్ ఎంత ఎక్సలెంట్గా చేశారంటే నేను అసలు ఇమాజిన్ కూడా చేయలేదు. ఈవెన్ ఫ్యాకల్టీ కోఆర్డినేటర్స్ అంటే చాలా బాగా చేశారు. నా పిల్లలేనా అనిపించింది నాకు. నా ఇన్స్టిట్యూట్లో థర్డ్ ఇయర్ ఫోర్త్ ఇయర్ పిల్లలు వాళ్ళు కాన్ఫరెన్స్ ఆర్గనైజ్ చేసిన విధానం ఇట్స్ ఫ్యాబులస్. అండ్ ఐ రిమెంబర్ యువర్ డైనమిక్ leadership and organization of the event. I really thankful to all of you. The students team organized the workshop is also marvelous. And Dr. K. Ramudu sir and Dr. K. Saujanya madam and CH Pavan sir and Abdul Mukim done very wonderful job. Special thanks to all my department faculty members and staff and student teams. My special thanks goes to Dr. Amit, CEO of Data Tech Labs, and Gopi Raja, CEO of Floppy Drone Technology Private Limited, Gupta from Qualcomm, and Bikshala sir from KU, and Srinivas Rao sir from NATW, and Sushant from CBIT, and Rohit. Special thanks to Professor Sridhar sir for accepting our invitation. Thank you sir, thank you very much for your support to the organization. And very special thanks to the man behind this particular IC3T 2023, ప్రొఫెసర్ కె అశోక్ రెడ్డి సార్. ఒక సింపుల్ వర్డ్ చెప్పారు, మీకేం కావాలంటే అది మేము అరేంజ్ చేస్తాము, వన్ వర్డ్, దట్స్ ఇట్. సో థ్యాంక్ యూ వెరీ మచ్ సార్ ఫర్ యువర్ సపోర్ట్, వండర్ఫుల్ సపోర్ట్ టు దిస్ వన్. అండ్ స్పెషల్ థ్యాంక్స్ గోస్ టు మై డిపార్ట్మెంట్ హెడ్ who continuously working from last 30 days, and he is roaming from Block 6 through to Block 4 for the appointment of principal and arranging necessary approvals. Thank you very much sir for taking all those pains. Thank you all for your wonderful support to IC3T 2023, and thank you all for your support and being with me. Thank you.
Thank you, ma'am. Without your guidance, IC3T 2023 would have not been possible. Your inspiring character made this conference a successful event. We once again thank you, ma'am. Now we have a special video from Ramesh Gupta of Qualcomm India.
Ramesh Gupta is a senior staff engineer and manager at Qualcomm India. He completed bachelor's degree in Osmania University and also worked as Linux design and development engineering at Texas Instruments, USA. He has over 30 years of experience as technical consultant for process communication, Android, QNX platforms.
We request to play the video.
I am Ramesh Gupta, working as a senior engineering manager in Qualcomm India Private Limited. Our company works on latest technologies. I will explain a bit further. So, Qualcomm is a semiconductor company which works on the latest technologies like modem and 4G, 5G, and upcoming 6G, and IoT, industrial IoT, automotive domain, and AI. I will give a brief about what are these technologies. If you use your mobile, I think everyone has your mobile, right? So just check your mobile. So every mobile has a modem. So we work on that. So now you may be talking, you may be hearing about the 5G. So we are already pioneers in the 5G. So upcoming 6G we are working on. And I think most of you people are using the ChatGPT. Are you? So the ChatGPT works on the cloud, whereas think of a situation where you don't have any access to the cloud, and you need access AI. So AI working on the edge means AI is working on your device. It is called AI edge. So this will be the going forward. It will be the emerging technology, because think about a scenario like where your car is driving at 100 km per hour at a remote area, and your car you are enabled in ADAS, so automatic driving assistance. So ADAS is a AI. If there is no cloud connection, there is no connection, how does it work? It requires the AI and the device. So that is where that AI and edge will be the future. Another thing is IoT, industrial IoT, where you need a lot of information from the different units and capture that information. Based on that when you take some decision. Where human cannot enter into some of the industrial area. So IoT has a complete setup of different sensors returning the data to the centralized system, and security like connected cameras and Wi-Fi 7, which will be the huge bandwidth for your router. So these are all the technologies we work on. If you think about the future of the technologies in semiconductors, so it will be the AI, cloud computing, and IoT and automotive. So these are the areas where enormous opportunities are available. You could be able to think a bit bigger, where you can come up with a different use cases. AI models are used in anywhere. It will be part of anywhere. So you are replacing lot of manual work with the machine. Think that you had some 1,000 acres of farm, and there is a one place, some 100-meter area, it is infested with some fatal pests that need to be removed as soon as possible. So that can be done by an AI drone. You send a drone and it will find out and it will check that one. If it is really some problem, and it will fix it. So this is one use case I'm talking about. There will be multiple use cases like this, where you are able to disrupt technology in daily life. AI and edge will be the definite use case, and
Thank you, Ramesh Gupta sir, for sharing the valuable information. Our esteemed chief guest for today's valedictory, Professor Sridhar KV, is an associate professor in Department of EC at NIT Warangal. His research areas ranges from biomedical signal image processing to advanced signal processing. Professor Sridhar Garu has over many journal publications in the area of image processing and its applications. With multiple conference proceedings at IEEE, ICES and IEEE Computer Society to his name, Professor Sridhar Garu has published more than 20 papers as of today. He has also organized many conferences on advanced signal processing and is also a faculty advisor for IST student chapter. Sir, we are honored with your presence. Now I request Dr. Sridhar KV Garu to please address the gathering.
First of all, I thank you, and I don't want to extend my this one. Okay. Very important means, first of all, the idea of conducting the international conference. National conference are not at all available today, but international conference is the namesake to get a credit for the institute. But I have not seen lot of papers which have been in your website, which basically indicates that the people are being more convinced with the way in which, I think this may be second or third, I think. Third. So that is why you have a very good impact which is being seen by the other society. So please continue the same type of rhythm. But what I would like to suggest is that please go for a peer-reviewed publications, and coming to the mostly the research authors of the various papers. Please try to think of the real applications mostly on there, because once it is a EC department or maybe the EC department. One very important means very few papers what I observed is a real-time implementation, mostly on the hardware. So a lot of hardware modules are available ready-made, maybe with a very low cost. maybe less than like Arduino, Raspberry Pi, even the pink boards and so on. Please try to implement them and then try to experience in terms of the computation complexity. Because what the difference I am telling is that the majority of the people are other side, even the computer science people also working towards the or electrical engineers also going to work towards the algorithm development. But as a EC graduates, or maybe some, I'm excused with the other computer science if it is there, or electrical graduates, try to implement, because computer science or the software way of development is very easy. Lot of libraries, lot of supportive softwares, even the systems are available, but try to implement on a hardware platforms which really gives a quantification or the acceptability ratings in the peer reviewed journals. Whatever the conference papers which are done, you can extend it even further by adding some more extra in terms of the real world implementation, like a hardware implementation. Please try to think of in that direction and try to, all the best to you. Thank you, sir. Thank you for giving me opportunity.
Thank you, sir, for your wonderful words of wisdom. Once again, it is honor to have you here, sir. Now, I request any of the authors and participants to share their feedback.
A warm good evening, everyone, respected dignitaries on the dais and all the faculty coordinators of the dais. Myself, Sneha, I'm from final year of EC department. I'm very glad to be a student coordinator in this wonderful international conference. We learned a lot. The knowledge we gained in this overall session will be remembered further, and I especially thank Sridhar sir for the wonderful keynote address. It actually developed a zeal in me to learn more about low key matrix and also SVD. And I also thank our principal sir for encouraging this kind of international conferences. I don't think I will be having an opportunity to work under any international conference further. Here I am representing all the student coordinators of third year and fourth year. We had a great session and great time participating in this. Thank you.
Thank you, Sneha. Now I request our principal, Professor Ashaka Reddy Garu. Professor Ashaka Reddy Garu has a pillar of strength and support for IC3T 2023. Your commitment for fostering academic excellence and providing a nurturing environment for the research and innovation has been the driving force behind the conference success. Now I request Professor Ashoka Reddy Garu, Principal of Kids Paranga, to give a presidential remarks.
Thank you very much. Good evening, everyone. I welcome each one of you to this valedictory session of IC3T 2023. The chief guest of valedictory function, Professor K.V. Sridhar Garu, and guest of honor, Mr. Rohit. He has become very close to the student community through his workshop on machine learning. And the convener of the conference, Professor Rama ma'am, HOD Professor Raju, Dr. Ramadu, my colleague, Saujana ma'am, and Mukhim. Yeah, Pavan also involved in this, and my senior colleagues sitting here, and conference participants. Warm welcome to you, and my great gratitude to each one of you for having made this conference very much memorable in the history of the Department of ECE. In particular, the Department of ECE has really got benefited in numerous ways. And just now we have listened to the feedback given by Sneha, our student coordinator, would definitely be a memorable experience when you get exposed to the conferences of international standard. Undoubtedly, building on the experiences that we had in the previous editions of this conference, we could put improved efforts, and that could be clearly seen in the arrangements made by the team of students and the team of faculty members. And in particular, I take this opportunity to thank my colleagues Ramadu sir, Saujana ma'am, Mukim, and the HOD Professor Raju for his timely guidance, and most importantly the person behind organizing this conference for the last 3 editions also, Professor Rama Madam. She has really shown unclinched commitment for the department, and in particular we could not witness international conferences being organized by any other department other than the Department of ECE. And that is the sign of commitment from a senior faculty of this institute. Professor Rama Madam, thank you very much for all that you have done to the department and to the institute. Rohit, thank you very much. You have given a wonderful confidence to our students through your workshop, and you have clearly made a point very clear that the domain knowledge is not really essential if you decide to become data scientist or a person with skills in artificial intelligence. Thank you, Rohit. The underlined material, any person with any background can make career in data science and artificial intelligence. You do not have to worry about the programming. I think I'm sure Rohit has made it very clear. We have to develop the applications related to that. Professor Rama Madam, thank you very much. You have given the complete overview how the conference has been organized, and on my behalf also, on behalf of this entire fraternity of this institute, I once again thank our chief guest Naresh Garu, made all his time to make him present before you for the inaugural session, and he also delivered keynote address, being a very busy person at DRDL, Professor Sridhar. DRDL is scientist F. So thank you, Naresh sir. And equally, I take this opportunity to thank Dr. Kishore Kumar sir, and also Dr. Sujan and Matini Selladurai madam for having graced the inaugural session and also having delivered the one of the keynotes today. I also thank Professor K.V. Sridhar sir for the wonderful support you have given. Though we have given you very minimal time, sir, you accepted our request. We thought we should invite Professor Sridhar sir. Yesterday, Rama Madam put this proposal before me, and we thought extremely happy. You have witnessed the presence made by Professor Sridhar. We would continue. Definitely, this conference spirit would be continued, and we will take up to the peer-reviewed publications surely. Your inputs are very valid, sir. We have to make all the researchers to implement their ideas on hardware platforms. This is very essential, dear colleagues, very important point, clue Professor Sridhar has given, and implementing the idea on hardware platforms has become the hallmark for getting our papers accepted in SCI journals. And therefore, we should start working on implementing our ideas on hardware modules. Especially, we should take the laboratories as our platforms, mini projects and through major projects. I request Head Professor Raju and the convener Rama Madam to kindly think, and we should definitely think about the computational complexity of the algorithms which we are proposing. That's really great conference we had, and I take this opportunity to thank a wonderful team of students who supported this conference. Student team along with my lovely faculty team who made this conference very much memorable year after year, supported by all senior faculty members, and most importantly the participants who made this conference very much attractive, and especially the conference participants from abroad also presented papers in this conference. I take this opportunity to thank the award-winning paper contributors who are here. They will be taking their awards from our chief guest of today's evening. All in all, it is a great international conference that our institution has witnessed. We should put all our efforts to continue this series of conference and take it to the next level of standard. Wishing you all the best. All dear colleagues, have great year ahead, and we wish to see all of you in the next edition of this conference. Thank you very much.
We are grateful for your unwavering belief in our abilities. Thank you for inspiring and always supporting, sir. Thank you. May I now request Chief Guest of today's valedictory ceremony, Sridhar K. V. Garu, and Principal Professor K. Ashoka Reddy Garu to please present the Best Paper Award. The best certificate for the Best Paper Award goes to Malati Jawahar of CSIR, who has received a Best Paper Award for the paper title Comparing Ensemble Learning Algorithms to Improve Flight Prediction Accuracy.
Next, Momentos.
And I would request our principal sir to please facilitate our chief guest, Professor Sridhar Garu, with a memento and shawl. I also request our principal sir to please present the memento to Mr. Rohit. Now I request our principal sir and chief guest Sridhar Garu to please give away certificate of participation to the authors. Tulasi Bikku, Associate Professor, CSC Department, has presented a paper titled Optimizing Gene Expression Analysis Using Clustering Algorithms. Dr. Ura Subramaniam has presented his paper titled Smart University Application, IoT-based smart and random method to collect waste management system in university campus. Also request our principal sir and chief guest to please present the awards to the workshop participants. Syed Yusuf Rian. Mitesh Chandra Vangari.
Chakrala Sahasra. Dasi Rahul.
Gampala Sai Reddy.
CH Sai Krishna.
Last but not least, our esteemed coordinators of IC3T, Dr. K. Ramadu, Associate Professor, Department of ECE, and Dr. K. Saujanya Ma'am, Assistant Professor, Department of ECE, who have been guiding lights in this journey. Your mentorship, encouragement, and knowledge sharing have shaped this conference. We owe a debt of gratitude to you for your tireless efforts for having played a pivotal role in ensuring the smooth functioning of this conference. Your hard work, organizational skills, and dedication to detail have been invaluable. Thank you for your unwavering support and for going above and beyond in your roles. Now I request Dr. K. Saujanya Ma'am to please deliver the vote of thanks.
Thank you, Sucharit. Good evening, all. I feel privileged to propose vote of thanks on this valedictory ceremony of Scopus Indexing 5th International Conference on Computer and Communication Technologies 2023. I stand here today as a proud to express my heartfelt thanks to all those who have made this event possible. The success of the conference is a result of the efforts put by the presenters who shared the latest developments in their respective fields. Such an event is not possible without the hard work of the reviewers, to whom I am deeply indebted for their timely and professional opinions on submissions. First, I would like to thank our management who have always been the support for our initiatives and encouraged us to strive for the excellence. I thank all the editorial board members, national and international advisory committee members for their meaningful contribution to make this conference possible. I thank all the dignitaries during the inaugural session and the speakers who have accepted our request to deliver keynote address to make this conference an ideal platform for knowledge sharing. And I would like to express my appreciation to our chief guest, Dr. K.V. Sridhar Garu, Associate Professor, EC Department, NIT Warangal, who have taken time out of his busy schedules to grace this occasion with his presence. Thank you, sir. Now, I would like to thank Professor K. Ashoka Reddy, sir, our beloved principal, Kids Warangal, and conference chair, IC3T 2023, convener Professor B. Ramadevi Madam, Program Chair Dr. M. Raju Sir, Head of the Department ECE, and teaching and non-teaching staff of our department for their constant encouragement and support for organizing this conference. Thank you all. Now, I would like to thank all the authors who presented their research work on IC3T 2023 platform. I would like to thank the resource persons for the workshop, Rohit Sanam Venkatagaru, CEO, Data Vision AI, and the faculty coordinators, Sri E. Suresh Sir and E. Shushmita Madam, for successfully conducting the workshop on AML. I would like to thank my colleagues, Dr. K. Ramudu, Associate Professor and Coordinator of IC3T 2023, and co-coordinators Abdul Mukim and CH Pavan, Assistant Professors in the Department of ECE, who have supported me in all aspects for smooth completion of the events in time. I would also like to thank all the student coordinators for their excellent support in helping the conference related works. I express my heartfelt thanks to press and media for a splendid coverage of IC3T 2023 events. Finally, Once again, I would like to thank each and every one of you for being a significant part of this conference and for forging a long association with our institution and also making this event a grand success. Thank you all. Thank you for giving me this opportunity.
Thank you, ma'am. As we conclude IC3T 2023, let us remember that this is not the end, but merely a milestone in our pursuit of knowledge and excellence. The experiences, lessons, and connections made during this conference will serve as the building blocks of our future endeavors. Let us carry forward the spirit of innovation and collaboration that has defined IC3T 2023 into our future endeavors.
Once again, I extend my heartfelt gratitude to all the dignitaries, organizers, coordinators, and participants who have made IC3T 2023 a grand success. Together, we have set a new standards of academic excellence, and I am confident that the knowledge shared here will contribute significantly to the advancement of cutting-edge technologies. Now, I request everyone please to stand up and let us sing our national song.
Thank you all, and may our paths be illuminated with light of knowledge, innovation, and progress. This is Sucharit
And Lekhana signing off.
I request all the faculty members to please join for a photograph.